hell, the machine, and the mission climbing out of the production abyss. Thank you. Thank you. People. Everyone wants to talk about ideas. Ideas are easy, they're clean, they're fun, they're like magic. And prototypes are trivial. Anyone can make a prototype. You can make one thing work one time, great. But production is hell. Production is so hard. Mass production, manufacturing in volume, reliably, consistently, and most importantly, with positive cash flow, it is excruciatingly difficult. It is why in 100 years, Tesla is the only American car company startup to be born and not go bankrupt. Hundreds of companies have tried. They all failed. Not because they didn't have good ideas, not because they didn't have prototypes. They failed because they could not cross the barrier of production. Production is the real barrier. It is the great bottleneck. Today, I want to talk about 2017 and 2018. We call it production hell, and that is not a hyperbolic phrase. It's not a PR soundbite. It is the most accurate description of that experience. It was a deep, dark pit of agony, extreme stress, and relentless despair. And it almost killed us. It almost destroyed Tesla. And the lessons we learned from crawling out of that pit, lessons in leadership, in engineering, and in reality itself are what define us today. It's the reason we're still alive. Part one, the abyss, betting everything on Model 3. To understand the hell, you have to understand the stakes. The Model 3 was not just another car model. It wasn't a side project to get a little more revenue. The Model 3 was the point of the company. Look back, our first master plan, which I wrote over a decade prior, was simple, and we published it for the world. Step one, build a low-volume, expensive sports car. That was the original Roadster. Step two, use that money to build a more affordable, higher volume car. That was the Model S and Model X. Step three, use that money to build a truly affordable mass market car. Step four, provide solar power. That was it. The Model 3 was step three. It was the culmination. It was the lever to actually finally accelerate the world's transition to sustainable energy. You don't change the world with $100,000 cars. You change the world with a great $35,000 car that millions of people can buy. Everything we had done, the Roadster, the S, the X, the first Gigafactory, it was all just preparation for this moment. If we failed at Model 3, the entire mission failed. The entire Tesla experiment would fail. It would prove that electric cars were just a niche luxury toy for the rich. It would set back the transition to sustainable energy by decades, maybe forever. So we bet the company. We raised billions of dollars and built massive automated production lines in Fremont, Nevada, believing we could make the leap from craft manufacturing to automated mass production. I promised that we would be producing 5,000 Model 3 seconds per week by the end of 2017. 5,000 a week. That was the magic number. That was the number that would get us to profitability and prove the business model. The reality was a disaster. In all of Q4 2017, the last 3 months of that year, we managed to deliver a total of 1,542 cars. Not 5,000 a week. 1,500 inches an entire quarter. We weren't missing our target by a few percent. We were missing it by 90%. And we were out of money. While we were trying to fix production lines that didn't work, we were bleeding money like crazy. The analysts were right about that as much as they seemed to gloat. The giant factories, the thousands of employees, the capital cost for robots, it was all expense going out and no revenue coming in. Bloomberg's data later calculated we were burning about $7,430 every minute. Think about that. Every 60 seconds that ticked by, $7,400 was gone. I said this later, and people thought I was joking or exaggerating. I was not. We came very, very close to bankruptcy. There were points in mid-2018 where we were single-digit weeks from dying. Imagine that feeling. Everything you've built for 15 years. Every sacrifice from thousands of people who put their faith in this company, the entire mission for a sustainable future, all of it about to go up in smoke. There's a quote I use a lot: being an entrepreneur is like eating glass and staring into the abyss of death. This was the abyss. We weren't just staring at it. We were dangling over the edge, our toes slipping, and the glass was everywhere. The Wall Street analysts were writing our obituaries. The short sellers, the people betting against us, were having parties. They were on TV saying we were a fraud, that we were a cult, that I was a liar, that we could never mass produce the Model 3. And the scariest part was in the spring of 2018, we were on the verge of proving them right. Why? Why was it so bad? Part 2, my mistake. The hubris of automation and the parable of the flufferbot. It wasn't because our team wasn't working hard. God, they were working themselves to exhaustion. They were giving everything they had. No. The reason we failed so spectacularly was me. It was my fault, 100%. I had a vision of the factory of the future. A fully automated factory, no humans on the line, lights out, robots moving in a blur, building machines at supersonic speed. We called it the alien dreadnought. We believed the true competitive advantage of Tesla was not the car. It was the factory. It was the machine that builds the machine. And I still believe that is true, but we got it fundamentally wrong. We over-automated too soon. We were arrogant. We tried to automate things we absolutely should not have. We tried to automate processes we didn't even understand. The result, when Gail King from CBS came to tour the factory, I pointed at the mess and told the truth. We had a crazy, complex network of conveyor belts, parts moving up and down, side to side, all over the factory. It looked impressive. It looked like a scene from Westworld, and it did not work. It was constantly breaking down. One sensor would fault somewhere, and the whole network would stop. One robot would be misaligned by 1,000th of an inch, and the line would stop. Our production rate, much of the time, was 0. We had built a machine that paralyzed itself. I'll give you the most idiotic example, and it really summarizes the whole problem. It's become famous, but the real story is even crazier. It is the parable of the flufferbot. Yes, the fluff robot. No, I'm serious. Here's the problem. On top of the Model 3 battery pack, the original design called for a fiberglass mat. It was essentially a piece of fluff. It was supposed to be for acoustic dampening, a sound deadening mat. And we tried to automate the placement of this fluff. Now, picture this. We had an incredibly complex robot. It had a sophisticated machine vision system. It had to look at a pile of fluff, identify a piece, pick it up, and it turns out robots suck at picking up fluff. The human hand is an engineering marvel. It can pick up fluff. It can pick up a steel block. It is incredibly adaptive. Robots are rigid. The flufferbot constantly failed. It wouldn't pick up the fluff, or it would pick it up and drop it, or put it in the wrong place. And the worst part, every time it failed, the entire battery module assembly line stopped. The entire multi-billion-dollar Model 3 production line was being held hostage by a robot that couldn't pick up a piece of fluff. Meanwhile, a human could stand there and do it perfectly, nearly 100% of the time, without thinking. So I'm there at Giga Nevada, staring at this stupid multi-million-dollar machine, struggling with a piece of fluff. It is killing the company. And finally, the frustration led me to ask a basic question we should have asked at the very beginning. I turned to the engineers and said, wait, do we really need this piece of fluff? Silence. People look at each other. Well, it's for acoustics. I said, okay, let's test that assumption right now. Get 2 cars, build one with the fluff, build the other without it. Take them on the road. Measure the cabin noise. We did. Guess what? No discernible difference. Nothing. 0. We had a hyper-complex machine trying to automate a task that humans are 1,000,000 times better at, to install a part that was completely unnecessary. That was production hell in a nutshell. It was the peak of engineering hubris. It was a failure to think from first principles. We ripped out the flufferbot immediately. We deleted the part from the design, and the line started moving again. And that's when I went on Twitter and said the thing that the entire auto industry considered heresy. I tweeted and I meant it. Excessive automation at Tesla was a mistake. To be precise, my mistake. Humans are underrated. We had treated the factory like software. In software, you can automate complexity. You write the code, it runs a million times perfectly. In the physical world, complexity is your enemy. The slightest variation, a small misalignment, a piece of debris on the floor, a piece of fluff that's a slightly different shape, breaks everything. We had to bring humans back onto the line, not because we were giving up on automation forever, but because we needed to learn. We needed the flexibility, the adaptability, and the problem-solving ability of humans to debug the mess we had made. And we needed humans to teach us how to build the car before we could teach the robots. Part 3, leadership in the trenches. I'm not leaving. Okay, so here's the situation. Spring 2018, we're on the verge of bankruptcy. The automation is a disaster. Our production targets are a joke. The company is collapsing in real time. What do you do as CEO? A lot of CEOs, especially the MBA type CEOs, the ones who are trained to look at spreadsheets, what would they do? They'd schedule more meetings. They'd demand more PowerPoint presentations. They'd ask for status reports. They'd form a task force. They would yell at people over the phone from their nice office, from their ivory tower. They would manage remotely. That is useless. It solves nothing. When you are in a war, do you want your general in a comfortable bunker miles away looking at a map? Or do you want the general on the front lines sharing the risk, seeing the reality of the battle? There's a saying, no one bleeds with the prince in the palace. Armies fight a lot harder if they see the general on the front line. So I made a decision. I moved to the Fremont factory. I told the team, I am here. I am not leaving until we fix this. I will sleep here. I will work here 24/7 until this machine is working. I wanted my desk in the worst place. I moved it to the end of the production line, the most difficult part, where every bottleneck and quality problem was visible. And yes, the press made a big deal about this, and it was real. I started sleeping at the factory. I didn't have time to go home. I didn't have time to go home and shower. It was a waste of time. Driving home was 30 minutes. Driving back was 30 minutes. Showering, changing, that's 90 minutes. I could be solving problems. Every minute mattered. We were in a race against a financial ticking clock. At first, I had a couch in a small conference room near the line. It was terrible. But then I realized that was wrong. It was still isolated. It was still an office. So I stopped using the couch. I started sleeping right on the factory floor, right out in the open. I'd bank a couple of cushions and sleep or try to under my desk. It was extremely uncomfortable. The floor is hard. The lights are always on. It's always noisy. And when I woke up, I'd always smell like metal, dust. But I did it for a very specific reason. And it wasn't because I'm a masochist, although I think I might not be, but I'm not sure. I did it so the entire team could see me. I slept there in plain view so that when the day shift ended and the night shift began, when they did the handoff, they would walk past my desk and see me there. They needed to know viscerally, not through an email, not through an all-hands meeting, that I was there. That I wasn't off somewhere having a good time drinking Mai Tais on a tropical island, which I definitely would have much preferred to do. They needed to know that I was sharing their pain, that I was in hell with them, that I was not asking them to do anything that I was not willing to do myself. You cannot ask people for sacrifice while the CEO is on vacation. It is inauthentic. It destroys morale. The truth is, them seeing me sleeping on the floor made a huge difference. It showed everyone that we were truly all in this together, that the survival of the company was real, and they gave it their all. Some people criticized this, a lot of criticism. It's theatrics. They said it shows he's a bad manager. They said you don't see the CEO of Toyota or GM sleeping on the factory floor. And they're right, you don't. But Toyota and GM are maintaining a 100-year-old system. They are not trying to create a revolution. They are not on the brink of death. We were. We were trying to come back from the dead. We were in a fight for survival. And in a war, you lead from the front. That physical presence wasn't just symbolic, it was an incredibly effective management tactic. It eliminated information latency. In a normal company, if a technician on the line at 3 a.m. discovers a problem, where does that information go? It goes to the shift supervisor. The shift supervisor then waits until 7 a.m. to tell their manager. That manager might wait for the 9 a.m. meeting to tell the director. That director might write an email to the VP. And maybe 36 hours later, the CEO gets a filtered summary of the problem. 36 hours? We didn't have 36 hours. We were weeks from dying. By me being there, that technician could walk 50 paces at 3 a.m., duck under my desk, shake me awake and say, Elon, the XZY conveyor system is jammed. We think we need to cut it out and reroute it manually, but it will cost $50,000 in tooling. And I, half asleep and smelling like metal, could say, okay, do it, don't ask again. Just do it. Decision made in 30 seconds. No meetings, no PowerPoints, no bureaucracy. That is how you accelerate the iteration loop. You remove the layers of management and you put the decision maker right at the point of the bottleneck. That's why I was there. Part 4. Leadership is a verb, talking bolts and taking out trash. This leads to a larger philosophy on management. What is the job of a leader? My job as CEO, it is not to command. It is not to sit in strategy meetings. Your job as a leader is to serve your team. The team is not there to serve you. You are there to serve them. What does this mean in practice? It means my job is to find whatever is slowing them down and remove it. I am the chief obstacle remover. So I walked the line for hours. Every single day, I was at the factory almost 24/7. I talked directly to the technicians and engineers on the line, not their managers, them. What is slowing you down? What is your bottleneck? Is this process dumb? Why are we doing it this way? I didn't want a summary report. I didn't want a spreadsheet. I wanted the raw data. I wanted to hear from the person actually doing the work. They know what the problems are. The managers in the offices do not. And when they told me this robot keeps jamming on this corner, or we are always running out of M8 bolts at the station, or this quality check requires us to walk 200 meters, which is a waste of time. My job was to fix it immediately. And I would call the VP in charge and say, I am at station 42. This robot is jammed. Send an engineering team here right now and do not leave until it is fixed. Or, why are we out of M8 bolts? Fix your internal supply chain. I'll be back in an hour and I want to see a bin of bolts here. This is a style of leadership I call bottleneck-based leadership. I don't micromanage everything. God, I don't have time for that. I delegate almost everything. But I nanomanage only the most critical bottlenecks. A production system is only as fast as its slowest step. So my job is to find that slowest step, focus the entire power and energy of the organization only on that bottleneck, and break it. When it's solved, I move to the next bottleneck. Yes, that means doing the work. We had a PhD intern working that summer. Very smart guy, good school, on his way to his PhD. He gets a cryptic text message late at night from his boss. It just says, report to factory tomorrow morning with a GPS coordinate, a map dot, and a phone number. No context. He shows up with a bunch of other nerds, not knowing what's happening. They're taken to a shoe store and given a voucher for a pair of Red Wings boots. Then they're taken to the new GA4 tent we had just put up, and they are thrown on the line. Here is a guy who does theoretical research, and suddenly he is doing heavy manual labor, building cars. It was an all-hands-on-deck situation. Anyone who could be spared from office work was there. Engineers, interns, finance people, everyone was there pulling cables, installing tooling, and this intern tells the story. He's working, he's tired, his shoulders are aching. Robots don't get sore shoulders, he said. And he says, I look down the line a bit and there's Elon torquing bolts. Yes, that's true. I was there on the line torquing bolts because if the line needs a person to torque bolts to keep moving, I will torque bolts. If the line needs someone to take out the trash, I will take out the trash. A leader must be willing to do any job. No task is beneath you. Your sacrifice must be commensurate with the sacrifice you ask of your team. When your team sees you there, in the trench, torquing the same bolts they are, they will work harder. This style of leadership, it's not pleasant. It is brutal. People were burned out. We asked for immense sacrifice, and anyone who got in the way, or anyone who valued process over outcome, was removed. It was a wartime environment. It inspired the people who were mission-focused, and it crushed the people who couldn't keep up. There were legitimate complaints about working conditions and stress. I even made a promise to meet every injured worker, and I couldn't keep it, because if I had, I'd spend the entire year just in meetings. It was an impossible balance. But we had to choose between being a comfortable place to work and surviving. We chose survival. Part 5, the engineering battles, batteries, and the tent. So what did we fix? Frontline leadership is necessary, but it's useless if you don't solve the fundamental engineering problems. There were two great battles, two primary bottlenecks that defined this hell. Battle 1, the giga bottleneck. Ironically, the biggest problem, the real bottleneck that held us back for months, wasn't even in Fremont. It was hundreds of miles away at Gigafactory 1 Inch, the Nevada desert. This is where we assembled the small cylindrical battery cells into modules. 4 of these modules make a complete Model 3 battery pack. This was the area where we had gone furthest with the alien dreadnought vision. We had hired an outside supplier, a famous German engineering firm, to design and build this fully automated module assembly line. They failed miserably. Their system was too complex, too delicate, and it didn't work. It was constantly faulting. This is one of the areas where we had to temporarily revert to a manual or semi-automated process, literally. We had to rip out the supplier's multi-million-dollar equipment and have Tesla engineers redesign the whole thing themselves. We rewrote all the control software from scratch. We flew in hundreds of technicians from our partner Panasonic to help ramp up the raw cell production. Because our line was so bad, we weren't even using all the cells they could make. At the peak of this crisis, we had brilliant Tesla and Panasonic engineers assembling battery modules by hand, just to get cars out the door. It was an incredibly expensive lesson in vertical integration. If you outsource a core process, a critical bottleneck, and your supplier fails, you die. You cannot control your own destiny. From that moment on, we decided we would design and build our own core manufacturing systems. Battle 2, the Fremont bottleneck. Okay, so we start to unscramble the battery mess in Nevada. Modules start flowing to Fremont. Great, now we have a new bottleneck. We didn't have enough general assembly capacity. General assembly is where you attach the doors, the seats, the wheels, where all the parts come together into a final car. Our GA1, 2, and 3 lines were full. We needed another line, GA4. The problem? In the auto industry, building a new factory, building a new assembly line takes a year, at least. We didn't have a year. We had a few weeks before we ran out of money. I'm walking the Fremont factory parking lot. I'm with Jerome Guillen, one of our best engineers, our problem solver. We are desperate. There's no space. There's no time. And we looked at the empty parking lot behind the factory. And one of us said, why don't we just build it right here? You mean outside? No, in a tent. Yes, a tent. A giant temporary structure, a sprung structure. The entire auto industry, all the experts in Detroit, Germany, Japan, they laughed at us. The headlines were brutal. Tesla is building cars in a tent in the parking lot. They're finished. This is the sign of desperation. They were right about one thing. It was desperation. But here is what happened. In 3 weeks, we erected that structure and built an entirely new general assembly line from scratch inside it. It was a literal all-hands-on-deck effort. That's where that PhD intern was torquing bolts, engineers, interns, office staff. Everyone was out there pulling cables, installing tooling, and here's the amazing thing. It worked. It didn't just work. The line in that tent, it was better than the line inside the building. Why? Because we had no time to make it complicated. We had no time for stupid automated conveyor networks on a second floor. Desperation forced us to be simple. It was a straight line, a simple straight line. Parts came in one end, cars went out the other. Everything was on the ground. People could see the whole line. You know, if there was a problem, they could yell and run over and fix it. I tweeted at the time, and and it was 100% true. Lower capital cost and slightly higher quality than the traditional line. That mock tent, that forced simplicity, it became the Gigafactory formula. It was the template we used to build Giga Shanghai in 11 months, which everyone also said was impossible. Desperation forced us to be simple, and that simplicity became our greatest innovation. 5,000 cars. With the battery line being debugged and GA4, the tent running, we made a mad sprint for the finish line. The last week of June 2018, it was the end of Q2. We had promised investors, we had promised ourselves, people were working 120-hour weeks, everyone was exhausted, and we did it. At about 5 a.m. on Sunday, July 1st, just after the quarter closed, the 5,000th car for that week rolled off the line. The whole factory erupted. Just an explosion of joy and relief. People were cheering, hugging, crying. It was a mass celebration. I sent an email to the whole company. I still remember what I wrote. I said, I think we just became a real car company because we had done it. We had done the thing everyone said was impossible. We had climbed out of hell. Part 6, the philosophy forged in fire, the algorithm. The hell was painful. Don't get me wrong, it was brutal. But it taught us how to think. It forged all of that pain, all of those stupid mistakes into a philosophy, a process, an engineering approach that we now apply to everything we do. I call it the algorithm. It's only 5 steps. It sounds simple, but doing them in the right order is incredibly difficult. The natural human tendency, especially for smart engineers, is to get the order wrong. I have to constantly remind myself and the team of this order. All of production hell happened because I reversed the order. I put step 5 first. Here is the algorithm. Step 1, make requirements less dumb. This is the most important step, and it is almost always skipped. All requirements are wrong. To some degree, they were given by a person at some point in time with incomplete information. Never accept a requirement as if it came from God. You must question it. Be ruthless. A requirement should never come from a department. Never accept a requirement from the legal department or the safety department. A requirement must come from a person. You must have the name of the person. If you don't know the name of the person, you can't go back and question them. Is this requirement sensible? Is it born from a false assumption? Is it obsolete? The fluffer bot is the perfect example. The requirement, we need an acoustic dampening fluff mat. That was a dumb requirement. It was based on a false assumption. Questioning the requirement deleted the entire problem. Requirements from smart people are the most dangerous because people are less likely to question them. But everyone is wrong. I'm wrong. Everyone is wrong some of the time. So, question. Even if the requirement came from me, especially if it came from me. Step 2, delete the part or process. This is my favorite step. After you have questioned a requirement, do not try to optimize it. Try to delete it. The best part is no part. The best process is no process. If you can delete a part, you also delete all the suppliers for that part, all the logistics requirements, all the factory space to store it, all the robots to install it, all the quality check processes for it. That entire chain of complexity vanishes. I tell my team, delete the part. If you do not end up having to add back at least 10% of the things you deleted, you did not delete enough. We deleted the fluffabot and the fluff. We deleted the crazy conveyor network. When we designed the GigaPress later, we deleted 70 different parts for the Model Y rear body and replaced them with one single casting. That is step 2. This is the core difference between continuous improvement and first principles thinking. Continuous improvement is, how do we make this 5% better? First principles thinking is, does this need to exist? Always start by deleting. Step 3, simplify and optimize. Only after you have tried your hardest to delete a part and failed, it is truly necessary. then you simplify it, and then you optimize it. This is the biggest trap for smart engineers. The most common error of a smart engineer is to optimize a thing that should not exist. They get handed a dumb requirement, and instead of deleting it, they immediately jump to step 3 and spend months brilliantly optimizing it. That's exactly what we did with the FlufferBot. We had genius engineers trying to optimize the vision system and the grasping algorithm of the robot. They were wasting their time, their talent, optimizing something that should never have existed. The tent was a great example of step 3 done right. We could not delete the general assembly line, we needed it, so we were forced to simplify it. No mezzanine, no complex conveyors, just a dumb, straight line, and it worked better. Step 4, accelerate cycle time. Once you have a process that is actually necessary, has been simplified and optimized, now you make it faster. This is another critical step. Don't try to accelerate a stupid process. As I've said, if you're digging your grave, don't dig faster. Make sure you are doing the right thing first. But once you're sure, obsess over cycle time. Every second saved on a process that repeats millions of times makes a massive difference to output. Speed is the ultimate weapon in manufacturing. Step 5, automate. This is the last step. After you have questioned the requirements, after you have deleted everything possible, after you have simplified and optimized the process, after you have accelerated the cycle time, only then you automate it. The entire Model 3 production hell happened because I stupidly reversed the order. We tried to automate a complex mess of unnecessary parts. It was a recipe for disaster. This algorithm, these 5 steps, this is the philosophy forged in fire. This is the treasure we pulled from the ashes of hell. And it is the real machine that builds the machine. It is not a set of robots. It is a repeatable mental process for building factories. Part 7, the legacy of hell, from Tesla to SpaceX. The hell was brutal, but it made us stronger. It forced us to learn or die. What we learned in that mocked tent, we took it to Shanghai. Giga Shanghai was built from a mud pit to a mass-producing factory in 11 months. No one in the auto industry believed that was possible. They said it would take 3 years. We did it in 11 because we applied the lessons of simplicity, of straight lines, of the algorithm. What we learned in Shanghai, we improved for Giga Berlin and Giga Texas. In Texas, we're making even bigger leaps with mega castings. We have the largest casting machines in the world. Instead of welding 70 different stamped metal parts together to make the rear body of a Model Y, we stamp it in one single piece. That is the algorithm in action. Step 1 is the requirement the rear body must be 70 parts dumb? Yes. Step 2, can we delete 69 parts and that entire complex robot welding shop? Yes. Step 3, simplify it to one piece. That is the legacy of hell. And here is the really important thing. These lessons, they are not just for cars. They are for everything. At SpaceX, we're trying to make life multiplanetary. It's why I started the company. That requires not one rocket. It requires a fleet of thousands of starships. Thousands. The traditional aerospace industry, companies like ULA or Arianespace, they build 2 or 3 rockets per year. A single rocket engine like the BE-4 can take 2 to 3 years to build. It is a craft, artisanal, expensive model. It's a joke. You cannot get to Mars that way. You cannot become a multiplanetary civilization at that pace. So what are we doing at Starbase in Boca Chica? We are applying the Model 3 mass production philosophy to rockets. People see us building Starship prototypes. They see us roll them to the pad. They see us flight test. And yes, occasionally we blow a few up. We make spectacular fireballs. And the media, the experts, they call it failure. They laugh. They don't understand. It is not failure. It is iteration speed. We are applying the algorithm in real time. We build, we test, we learn. Okay, that valve stuck. That tank flap design was dumb. Step 1, delete that flap design. Step 2, simplify the plumbing. Step 3, and we build again in a matter of weeks. The experience from Tesla's production hell is what allows Starship to exist. It taught us that the factory is the weapon, the rate of production is everything. Prototypes are easy, production is hard. We are trying to get through the production hell for a city on Mars. I said this in an interview, and people thought I was arrogant, but I believe it to my core. At this point, I think I know more about manufacturing than anyone currently alive on Earth. That is not because I am smarter than anyone, not at all. It's because I've been in the inferno. I have been forced to learn or die. Most other leaders are never faced with that choice. I have had to solve for mass production and complex ultra-high reliability production. I have lived on the factory floor. The real bottleneck for humanity is not ideas, it is manufacturing. It is the ability to turn the ideas in our heads into physical reality at scale, reliably, and affordably. That is the great lesson. Part 8, conclusion, why we fight. Looking back, those were the most painful, excruciating months of my life, without question. I was there on the factory floor, unbelievably stressed, tired to my bones, smelling metal dust. Our team suffered. The pressure was unimaginable. People sacrificed relationships, health, sleep. So why? Why do it? It's not worth it. It's not for money. It's not for the stock. If I wanted to make money, there are a million easier ways. It is because of the mission. It has always been about the mission. The mission of Tesla is to accelerate the world's transition to sustainable energy. That is not a corporate retreat buzzword. It's not a marketing slogan. It is real. Climate change is an existential threat. We must solve it. We are running a crazy experiment with the only atmosphere we have. We must move to a sustainable energy economy. And the Model 3 was the lever. It was the first mass market affordable electric car. If we failed, it would have proven to all the big automakers that EVs were just a luxury toy, a niche. It would have set back the transition for decades. That is why we had to fight. That is why we could not give up. That is why failure was not an option. The lesson of production hell is not just get your hands dirty. That's obvious. If you're not willing to do that, you shouldn't be in charge. The real lesson is deeper. The real lesson is, 1, pick a mission that matters. Work on something you believe in, something bigger than yourself, something you think is important for the future of humanity. 2, be prepared to go through hell for it, because if it's truly important and truly revolutionary, it is going to be excruciatingly hard. There will be times you want to give up. There will be times you think you are going to die. Don't. 3, when you are in hell, be on the front line. Don't hide in your ivory tower. Don't manage by spreadsheet. Go to where the problem is. Share the pain and the sacrifice. Remove the obstacles. Torque the bolts. 4, think from first principles. Use the algorithm. Always question requirements. Be ruthless about deleting stupid things. Simplify. Don't optimize what shouldn't exist. And 5, remember, humans are underrated. We survived, we got out, and we are stronger than ever because of it. Now, let's go build the future. Thank you.